was the first 2 weeks. That was only weeks 8 and 9. We got more to go. Let's do it quick. 10. What was week 10? What was that?
Diodes.
Yeah, diodes. Week 10, diodes. So when you look at these, p-n junction diodes, remember you need 0.7 volts, forward bias to open them up, reverse, no current. There's really 3 circuits. I'll let you go back to the homework. I'm not going to use my time. I'm not going to go back and draw. You can either forward bias it, you can reverse bias it. Forward bias current flows after you pay the 0.7 volts. So we'll do it real quick. So if I got 5 volts, I'll make this 1 kilo ohm to make calculations easy. Forward bias, 0.7 volts. That means this is 4.3 volts. Common mistake students will make is they'll try to put all 5 volts across the resistor, but you had to pay a 0.7 to turn the diode on. That will mean 4.3 milliamps. Reverse bias. No current flows. If there's no current, there's no voltage, which means all 5 volts is over there. Doesn't even matter that I don't have a diode resistor. Yeah.
Will you have any equations or examples that will be with germanium and silicon?
I could. I'll get there in a second. 5 volts. Oh, I'm sorry. 0.5 volts. If I do this, yes, it is forward biased, but it's not enough to open it up, so it's 0 current. Yes, germanium, I'll give you the voltage. It could be 0.2 volts. I also, if it's an LED instead of a p-n junction diode, I'll give you a voltage. So beware, I have done that before. Oh, it's a red LED. It has 2 volts on it. And then half the class goes 0.7. I'm like, it says on the schematic and in the problem too. So, yeah, read my problems. Because LEDs have a different forward voltage. Yeah, go ahead.
What about the 0.7 to turn it on?
That's what we just did. 0.7.
Yeah, but the bottom one, why is it 0.5 across?
Because you've only got 0.5 volts, so you can't get to 0.7.
Correct. So why is it 0.5 across the diode?
It is 0.5.
I thought it had to get to
It has to get to 0.7. It hasn't gotten there yet. Has to get to 0.7 to open up and let current flow. So there's
Like
no
current flow.
Yeah, there's no current flowing, so there's no voltage on the resistor. So where is the voltage? It has to be on the diode. Remember my example in class that this is like a valve with water. It's pushing in the right direction. It's just got not enough pressure to open it. Okay, so just watch these in case, because like I said, a lot of times I'll give you like an LED instead of a p-n junction. And then I'll give you the forward bias. Use the forward bias. If I say it's 2 volts forward, then you make that 2 volts, and that's only 3 volts. Yeah, if it's germanium, I'll tell you 0.2 volts. Those don't come up very often, but it is mostly an audio thing. It's like people pay ridiculous money for new old stock germanium diodes from 1966 or something. Also review the clipping circuits because you did a whole section on that in the lab. Just make sure you understand them. The big thing with the clippers is you want to make sure you're looking at your peak voltages and not your RMS voltages. So you are clipping at 0.7 volts. If you have a 0.7 volt RMS circuit or signal, that means it's going up to about 1 volt peak. So chop the top off. That's where you need to know that RMS versus peak. Most or everything you'll get will be DC, but the AC part is a valid question. All right, week 11. Transistors. So that's the one where I made you go through in the lab. And I said, hey, we're going to measure this current in, and we're going to measure this current. We use voltages, Ohm's law. And then beta is equal to the collector of the base current. So So this is basically week one, the first week of transistors is how do they work? I had a whole series of homework problems in there where you measured, calculated voltages and currents. That one is totally fair game for the test. In fact, I put out there before an open question says, design a lab experiment to find beta of a transistor, which is totally fair game because at 11 was find beta of a transistor. So make sure you can do that. Make sure you can do the switching circuit. So in the homework, we had one that was like a resistor switch to turn on this switching circuit. And you had a light bulb that would turn on. And it told you this voltage. So, you know, if this is open, well, there's no current here, no voltage here, no current here, no voltage here. So that entire voltage is across the transistor. If I close it, then this voltage will be on here, and it'll be on there because they're parallel, which will be this current and that current. So one like this, or review what we did. So like there were two problems in the last page of the homework with that. And then review the lab. You did a whole lab on this. So again, nothing on here is going to be a big surprise. You did a whole lab, gee, I'll put a problem on it. You did a whole homework set, gee, I'll pull a problem off of it. 12. Transistor amplifiers. So we did the common emitter amplifier. We had to go find, I showed you the entire method to go through and find those voltages and currents. And these voltages and currents. And put them, I had two tables, right? You did it in the lab again, you did several homework problems on them, where I said, go find the voltage, oops, I said R1, not R1, R2. Find the voltages, find the currents, find the voltages, find the currents. And you filled out the table. And you also found the voltages between these collector and base emitter, collector and emitter. Of an entire lecture from that week out on there. We have an entire lab on it. The final project, which I will hand out to you when I'm done with the lecture today, that's due like 10 days from now, so you gotta get on it, covers this. So trust me, I think transistor amplifiers are really important. So there will almost certainly be a transistor amplifier problem on the test. And there will be another one on the final. And it's the entire 50-point final project. So, gee. Like I said, I'm not trying to be mysterious about any of this. Everything on the test is stuff we've explicitly covered. Okay. I did spend the least time on those, not because they're less important, but just because that's what we've done the last 2 weeks. Well, 2 weeks before. What was last week?
Op amps.
Yeah, op amps. There will be op amp problems too. So, okay, a couple things here. Remember, we assumed the base current is approximately 0, and we assumed the base to emitter voltage is 0.7 volts. Those are assumptions we made. And I list those over and over and over when I go through these. Op amps, what are my assumptions there? The two inputs are identical, and the input currents are 0. And then we used those and did this last week in class. You can go back and look at it. And we solved if I have a non-inverting op amp there's the feedback resistor. There's the ground resistor. It has a gain. What was the gain? It's 1 plus the feedback over the ground. You should be able to find all the voltages and all the currents on here, just like I did in those detailed examples in class. Hopefully you did last week's homework in lab and got it already, so you're up to speed on this stuff. This is the inverting op amp. Input resistance, feedback resistance, the gain on it was minus RF over RN. When you did the lab, you found out those gains on it were pretty much right on, right? If you count, I think in the lab you got minus 10 for the inverting, and you found out, hey, if I'm putting, until I start hitting the rails, my supply's not keeping up, I'm getting gains minus 10. And when the non-inverting, you got a gain of 11, and you were like, I put in 0.1 volts, I get 1.1 out, exactly 11 times more. So, I'll answer more questions. As I mentioned at the very beginning, this week's lab is a 555 lab. I will not put the 555 stuff on the test. So if you're going to put anything off this week, do the lab after the test.
There's 555 questions on.
No, there will not be, as I said. It will not be on the test. However, you had talked about a 555 because you did an entire project where you researched it, wrote up everything you knew, so you already understand it well enough. So I don't have to go through details on it. The lab itself should be pretty self-explanatory. Just list all the pin numbers on the little thing. You plug it in, you make sure those pin numbers are connected to the right spot, and it'll be matching. So, get the review homework done first. Hopefully you've got all the homeworks through, that done. If you don't, sorry. And before Thursday. Thursday, 10 a.m. I told the proctor you get 2 hours to do the exam if you would like. I'll write it so I think it's a 50-minute exam, so, but if people want extra time, I don't care. I won't be here at that time, there will be a proctor. There will not be anything on there that you have not seen on the last 7 weeks homework or labs. Only thing you might see on there, which I did in the first exam, is I might put like a breadboard in the circuit and say, draw the circuit on the breadboard, how you would build it. Because at this point, I should be able to just give you a schematic and you just say, hey, this is how it all connects to the breadboard. Nothing more involved than we've done. Or I've given a picture of a breadboard circuit and said, hey, draw the schematic for it. Those would hopefully be ones you would go, wow, this is a lot easier. I don't have to do any calculations. I just like draw it. Yeah.
4 resistor current
Yes.
on the op amps.
Yes.
See the same. Like, is it parallel or series? I don't know why.
They're neither.
They're neither?
Yeah.
Okay. So when you're calculating current and voltage.
So current, input voltage, right? Inputs are both the same. So this is the input voltage. That is the input voltage.
Okay.
So I want to find the current here. Input
Okay.
over that resistor. Give me the
That
current.
makes sense. Thank
Over here, out minus in to get the voltage across that resistor divided by the resistance. Up here, this is tied to ground, so it's 0. Therefore, that is 0 because they're both identical. Input minus 0 over this, so it's just going to take input voltage over that, will give you the current. And then I do 0 minus the output over this, which will give you a negative current because it's flowing back. So it's an inverting op amp. Okay, other things I mentioned at the beginning, because we're getting down to the end. What, 2 weeks? I think 2 weeks from today or 2 weeks from Thursday. I turn the final grades for you. Don't worry. Do this week. Next week's all review, so next week should be a pretty easy week. So all you're doing is doing some review stuff at the beginning of the semester. Final projects, I'll pass out. So as soon as we're done, it's just a soldering project. Probably no harder than the other two. In fact, easier probably. It's a little transistor amplifier. You're going to do the analysis, and you're going to hook it up, and you're going to measure it and see if it does all your, well, it's transistor. It'll be fun.